Hi everyone, my name is Frédéric Passeron and I'm part of the HPE Dev program team, and along with my colleague Patrick François and Denis Choukroun, at least, and Pramod as well, and Chris, we are happy to welcome you in this new HackShack session dedicated to an introduction to the REST API of the HPE Ezmeral container platform solution.
Thank you, Frédéric. So, hello. I think we have one student, one participant, and the rest of the team as well. So, welcome to this HackShack workshop about HPE Ezmeral Container Platform REST API. My name is Denis Choukroun. I'm part of the HPE Experience Studio organization, and I have more than 20 years of IT experience on various technology roles. And I am currently the program manager of the HPE Developer Community Program. So today, I will start with a brief introduction and overview of what is HPE Ezmeral Container Platform. And we will explore all together through a set of hands-on exercises, the steps you need to take to deploy, run, and manage applications by a programmatic access with HPE Ezmeral Container Platform. So this workshop is delivered through Jupyter Notebooks, and you will have the opportunity to participate to a set of hands-on exercises by following along with me. So at this point, I think that you have the information in the chat room to connect to the notebook system. So you will access it through your browser on the HTTPS, and the URL is notebooks.hpdev.io. And you should connect with your student ID that has been assigned to you by Frédéric or Patrick in the form of student 1 or student 2 or more. So it's student 1 to 50 actually. And the password for today to connect to your notebook system and account is STU Disco 2020. So STU in lowercase and Disco DISCO in uppercase, and the current year 2020. So with that, I will also connect to the notebooks. So I will switch to the Jupyter Notebook account. I'm using student 50 as user ID. Shall I restart, I think? My server. Okay, so once you are logged in case of issue, please put a note in the chat room, and Frédéric and Patrick will help you and assist you to connect. But if you are connected to your student ID on the Jupyter system, make sure that you navigate to the folder Discover and double click on it. You should see here one folder named WKSHP, HPCP API. Double click on it to open this folder, and you should see here a set of files. Some of them are with extension IPYNB. These are your Jupyter Notebook. And we will open the first Jupyter Notebook, which is readme first.ipynb. Double click on the file to open it. So let's put screen.
Yeah, F9, cool.
So what is a Jupyter Notebook? Jupyter Notebook is a mix of cells. These cells can be text cell or code cell. And to execute or run a cell and advance to the next one, at the menu bar at the top of your notebook, you will see a play button, which you just click on it to run the cell, execute the cell, and advance to the next one. So for this notebook README, you will see just a text file with a set of cells which are only text. And you click on Run to advance to the introduction to the HPE Ezmeral container platform. So what is exactly the HPE Ezmeral container platform? HPE Ezmeral container platform is a Kubernetes-based platform designed to make it simpler to deploy, run, and manage both cloud-native applications and non-cloud native applications with containers. If you click on Run button again to advance to the next cell, you will see here a high-level overview diagram of the HPE Ezmeral container platform deployment that has been put in place to support the delivery of this workshop. On the right side of this picture, you see a set of hosts. These hosts has been grouped into one Kubernetes cluster named K8S cluster 1. And this cluster has been assigned a tenant named K8S Act tenant. A tenant is a group of users that can represent a company, an organization, a business unit, or even an application, specific application or specific project. And this tenant is assigned a set of resources, so a quota of resources, such as the GPU, memory, CPU, storage, as well as the resources of Kubernetes clusters. Here, for this workshop, we are all members of the same tenant, K8S Act tenant, and we all share the Kubernetes cluster resources of the Kubernetes cluster managed by HPE Ezmeral Container Platform. And this Kubernetes cluster is under the direct control of the control host. So on the left side of the picture, you see the control host, which is part of the control plane of HPE Ezmeral Container Platform. This controller host handles user authentication as well as all REST API requests. There is also another physical element that is important when you interact with the HPE Ezmeral Container Platform is a gateway host. This gateway host is a proxy server that carries all client requests, such as the REST API calls, Kubernetes API calls as well, and it carries this traffic to the controller host or to the Kubernetes cluster managed by HPE Ezmeral Container Platform. And as you can see also in this picture, the gateway host is also the way users access their applications running on Kubernetes clusters. This is a shift through the service endpoint mapping running on the control plane. And the last element that is deployed out of the box when you install the HPE Ezmeral Container Platform on your software, on your infrastructure, the HPE Ezmeral Data Fabric, which was formerly known as MapR Data Platform, is deployed and provides the Kubernetes persistent storage for containerized application running on the Kubernetes cluster managed by HPE Ezmeral Container Platform. So with this background information, if you click on the Run button to advance to the next cell, we will start our first lab. The workflow of the lab, we have two labs. The first one is an introduction of the REST API and how to authenticate or obtain a valid login session to interact programmatically with HPE Ezmeral Container Platform. And the second lab, we will explore a series of codes, cells, to deploy programmatically both cloud native and non-cloud native applications. So to start with the lab 1, just click on the link lab 1. This should open the next notebooks. This notebooks is named WKSHP, HPCP, Intro, and Authentication. So in this first lab, I will talk a little bit about the basic forms of the REST API call, and we will see all together how you can obtain an authentication token, which is also known as a session location, so you can communicate programmatically with HPE Ezmeral Container Platform through its REST API. So click on the Run button to advance to the next cell. And in its most basic forms, the HPE Ezmeral Container Platform REST API has two parts. The first part is an HTTP verb, and the second part is what we call the API endpoint URL. The verb, an HTTP verb, is the operation you want to perform on a specific object or resources on HPE Ezmeral Container Platform. The typical verbs you use are get, post, put, patch, and delete. The get is used to retrieve properties of existing object or resources from the HPE Ezmeral Container Platform. You will use a post API call request when you want to create an object or a resource. You use a delete to delete an existing object, and put and patch verb to update an existing the properties of an existing object. Now, as for the API endpoint URL, in our HPE Ezmeral Container Platform deployment, as explained in the introduction of the workshop and in the picture, in the diagram, you see that the communication and the interaction with HPE Ezmeral Container Platform REST API is through the gateway, and this is achieved on port 8080. So for our workshop, when we will make REST API calls against the HPE Ezmeral Container Platform, we will use the endpoint URL in the form of HTTPS gateway name or IP address on port 8080 with API/v2 and against the object of the resource we want to create or fetch information or delete. So in the next step, we will see how to get an authentication token to interact with HPE Ezmeral Container Platform. In HPE Ezmeral Container Platform, all the interaction with the Ezmeral Container Platform must be authenticated. And this is achieved by obtaining or retrieving a session token known as a session location. And you do this by sending a post request for the object session, and you provide in the body of this request your username, password, as well as the name of your tenant name. This will define the context of the operational context for your user tenant. Then, from the response of this post request, you will obtain the session location, and you will use this session location on each and every subsequent request you will do against the HPE Ezmeral Container Platform REST API. And this is done by setting an HTTP header in your request with a key name set to XBDS session and the value set to the session location you obtain from the post request. So now let's see this in action we will use curl. Curl is an HTTP client that will allow you to send and to make REST API calls to the HPE Ezmeral container platform. So the next series of cells are what we call code cells. They are bash or shell script that are used to make these post requests and subsequent requests to HPE Ezmeral container platform. So make sure that you run and execute the first cell to define your operational context. So here we will define your username, your password, and your tenant name, as well as the API endpoint to reach and to communicate with HPE Ezmeral container platform. So run the cell. You should see a response after the execution of this cell. Your operation context is a student ID on the tenant K8s ACK tenant. You will notice that when you execute a cell code on the left side of the cells, you may see either a number or a star or an asterisk. The asterisk means that the cell is under execution, and when you get a number, this means that the execution is completed. So here we can now execute our post request using curl command, and you see that the post request is against the object session, and we provide in the body of the request the username, the password, and the tenant name. And from the response of this post request, we will save the session location into a variable called session location. And we will use this session location on subsequent call to query information about the session we have just created. So first, let's execute this curl post command through curl. And you should see the response of this post request in the form of this is your session location, and the session location or the full path of the session location is in the form /API/v2/session, and a series of characters and digits, which is actually your session ID. And you will see that we will need to specify this session ID later when we want to gracefully close our interaction and our login session with HPE Ezmeral container platform. So now let's make a subsequent call. So you see an example here on how we can fetch the properties of a session object we have just created with the post request. So here we use a GET request, and you see that in the header of the request, we have specified the session, the key xBDS session with the value of our session location. And you execute the cell by running or clicking on the play button. And the output should show you detailed information about your session you just established with the HPE Ezmeral container platform. So you can see your username, your tenant name, your role on the tenant. You have been assigned the admin role. And if you look at the session expiry time here, you will see that, or you will understand that your session location token will remain valid for 24 hours. After these 24 hours, should you want to interact again or to continue interaction with the HPE Ezmeral container platform through its REST API, you will have to re-establish a new login session with a post request. And finally, as an example of a delete operation, we will just use the delete operation here against our session object for our session ID, still by specifying and authenticated this request with our XBDS session value set to the session location, and we will close our session location. This is always a good practice, and this is actually a best practice in REST API programming to gratefully delete or closing the login session. So we execute it, and you should see the response of this delete request in the form of 204 no content. This means that the object session has been deleted, so it's no longer existing. So with this information in mind, we can now start our lab 2. So just click on the lab 2 to open the next lab. But before we continue, is there any questions or issues? No?
So far, I don't think
Everything is
there are.
on, everyone is on track?
Yes.
Yeah.
No issues. I mean, both of them are running smoothly, it seems. So you can go on.
Okay. So do not hesitate to ask questions, or you can use, I believe, the
The
reaction
chat or
button, or the
yeah,
chat button, or reaction button to raise your hand if you have any question. So in this second lab, continuing with what we have learned in the first lab, I will walk you through the steps you need to take to deploy non-cloud native applications as well as cloud native applications. You will see the process or the steps, the sequence is exactly the same. So what we will do here is that as a tenant user, you will first establish a valid login session using a post request against the HPE Ezmeral Container Platform REST API. And using a subsequent REST API call, you will fetch the kubeconfig file for your tenant working context. This means that a kubeconfig file is needed to interact and access the Kubernetes cluster running and managed by HPE Ezmeral Container Platform. And once you fetch this kubeconfig file, you will use a series of Kubernetes API calls using the API client kubectl or kubectl. And you will use kubectl to deploy both non-cloud native applications and the cloud native application. So we will see that now. So the first things to do, again, is to make sure that you initialize your environment to define your student ID, your password, your tenant name, and the API control, API endpoint as well. So make sure that you receive your operation context is your student ID on the tenant K8s act tenant. And once you get this, you will first again send a post request to establish a new session, new valid sessions with HPE Ezmeral Container Platform. And you will use a get subsequent request REST API call to fetch the kubeconfig file. So let's do it. And on the left side of the screen, here you should see your student ID underscore kubeconfig. So your kubeconfig file should be created now, and you can open it by executing this next cell, the cat command with the kubeconfig file as input. And let's look at the content of this kubeconfig file. You will see that this kubeconfig file defines what we call the context. Here we have a couple of contexts, and your context, because you specify your namespace, your user ID, it will define the cluster that has been assigned to your namespace, KHS Act tenant, with the cluster name KHS cluster 1, and your student ID. This defines your Kubernetes context. And if you scroll down a little bit, you will see one parameter value here, HPCP token, which is the HPE Ezmeral Container Platform token of a session location. And this session location is the token of a session location of your current session you obtain using the post request you previously opened. So if you compare the value of a session location from the result of your post request and what you get here, it's the same. So this means that all your Kubernetes API calls will be authenticated using your session location specified here in the kubeconfig file. And the next step before you can use kubectl to deploy applications, containerized applications on the Kubernetes cluster, you need to tell kubectl where to look for the kubeconfig file. So for this, we define or we export an environmental variable named kubeconfig. So make sure that you execute the export or the cell with the export command and see the name of your kubeconfig file. By default, kubectl is looking for a file named config on your home directory, but here the kubeconfig file, which has been fetched through a REST API call, has been created on your current directory, which is a /discover/wkshp HPCP API. So this is not your home directory. So we need to tell kubectl how to find the information for your tenant and user in the context file, so in the kubeconfig file. And you can check by running the next cell, the kubectl config current context, your context or your operational context, which define your username, your tenant name, and the Kubernetes cluster you will use to create and deploy applications. So the next step is for us to use a Kubernetes API call to deploy a simple clone native application. This is a Hello World application. This Hello World application is referred as a stateless application because it does not require any persistence of data or any persistence of host name and network information. This application, when we will access it and when it is running, should return hello Kubernetes. So we will deploy now this application. To deploy an application using kubectl, you need to use an operation type, which is a Kubernetes API operation, such as create or apply. And you can use what we call an application manifest, which is in the form of a YAML file. And this YAML file describes the attributes and the elements that make your application. So here we predefine one YAML file. So you can open it by executing the scat command. And you can look at the file and the components that will be deployed. We will deploy a deployment object, which is a standard Kubernetes object. And we will also deploy another standard Kubernetes object, which is a service. So the deployment will control the containers for our application. This application will run a Docker image, which will be fetched from the Docker Hub. Here is the name of your image. And we will deploy 2 replica of this container. So we will have 2 containers also also called in Kubernetes pod. So we will have 2 pods. And we will have also a service. This service is used to expose our application outside the Kubernetes cluster. And you notice that this service is of type node POR. By specifying a node POR service, HPE Ezmeral Container Platform will automatically remap the port into a gateway port on our gateway host with a port greater than 10,000. And this will allow users to access their application running on the Kubernetes cluster. So let's first deploy our application using kubectl Kubernetes API call with the apply operation. And we will use the file, our YAML file, as input to create our application. So run the cell. After a few seconds, you should see the response of your Kubernetes API call in the form of deployment created and the service created with the name of your service and the name of your deployment. Then you will use the next set of commands to look at and check the status of your application or your pod. These are running your containerized application. We have 2 pods, so 2 replica of our application, as we specified in our YAML file. And you can describe the service, use the describe command to look at the detailed information about our service. And from this service, we will fetch or search for the node POR service endpoint on our gateway. So you run the next cell, which is a kubectl command with a describe operation against the service we have just deployed. And we just look for lookup for the word gateway. And from that, we obtain our remapped POR, which has been defined automatically by HPE Ezmeral Container Platform on our gateway. And to access it from the Jupyter Notebook here, you can use a curl command, which is the next cell, against this URL to connect to your application and verify that you get the expected message from your application. So your application has been deployed. So you see that it's very standard. It's a standard way of deploying a cloud native application on Kubernetes cluster managed by HPE Container Platform through authenticated API calls. Now, if you want to delete your applications, let's assume that you don't need it anymore, you can use a kubectl API call with the delete operations, and you provide as input of your delete operations your YAML file. And this will delete all the elements and components of your application for you. Any questions so far? No? Everyone is with me? No problem? Okay. So let's talk a little bit about KubeDirector. So KubeDirector is a key software element of HPE Ezmeral Container Platform. It is an open source project led by HPE, and it is implemented as a Kubernetes operator on every Kubernetes cluster managed by HPE Ezmeral Container Platform. And as an operator, the KubeDirector operator includes custom controller, as well as some custom resources, such as a Kube Director app and a Kube Director cluster. We will see and explore a little bit more in a couple of minutes these two elements. Just want to add something about Kube Director. Kube Director as an operator extend the standard Kubernetes capabilities to deploy, run, and manage analytic workloads with a focus on machine learning, deep learning, data processing, and big data applications and workloads. In general, these analytic workloads are multi-tier, scale-out, and distributed applications, and they are implemented as multi-node application clusters. In HPE Ezmeral Container Platform, these application clusters refer to application virtual cluster, where each cluster node of this application virtual cluster runs as a container on the Kubernetes cluster managed by HPE Ezmeral Container Platform. So it's important that you keep this in mind to understand the next set of exercises. So we can use the next command, the kubectl get Kube Director app, to get the list of Kube Director app applications that has been made available by the administrator of this platform to our tenant. So let's run this command. You see that for this example and this workshop, we have 3 Kube Director app defined on our application store. So, but what is a Kube Director app? It defines the application metadata. So let's observe what are these metadata information for an application by looking at 2 Kube Director apps. The first one is Spark application, which is a data processing application. And the second one, which is a much simpler application, is a TensorFlow application with an embedded Jupyter notebook. So let's run the first command, kubectl describe, for our Spark application. So what you can see here, if you scroll down a little bit, so you see that this is, of course, a Kube Director app object. And this Kube Director app object define the components that make our Spark application or our Spark application virtual cluster. We see that we have a set of role services defined for Spark. We have the controller role, we have the Jupyter role, and we have the worker role. All these 3 service roles will define and will make our Spark application when an instance of this Kube Director app is deployed on the Kubernetes cluster. This Kube Director app also define the image. So these are Docker Hub images that will be loaded into the container or into the pod to run as a container. It defines if when available configuration package to configure each node of our application virtual cluster. It defines the cardinality. The cardinality is the expected number of nodes per service role. So here, for example, for our controller role, we expect 1 node. But for the worker node, for example, on our cluster, we expect 0 or 1 or more nodes. So when you want to deploy a Kube Director app, you will define the number of nodes you want per service role. You also have here the persistent directories. These are the mount points that will need to persist beyond the lifespan of our containers. And finally, as part of the metadata definition in KubeDirector app, the KubeDirector app defines the service endpoints for all the elements and software elements that make our cluster. So this one is quite a complex distributed scale-out application. The next KubeDirector app, which is a TensorFlow application, if you run this kubectl describe command, you will see that one is much simpler application, which define the service role. We have here one service role. This service role will embed TensorFlow with the Jupyter notebook. Again, it is a Docker image from the Docker Hub. And it defines a set of services. So here we will have one service, actually endpoint, to access our Jupyter notebook. And you see there is no persistent directories or mount points defined on this application cluster. So now let's see how to deploy a KubeDirector app instance. The sequence of steps is very similar to any other kind of cloud native or applications. An instance of KubeDirector app is an object named KubeDirector cluster. So this will define our application virtual cluster for our KubeDirector app. To do so, we will use kubectl with an operation of create or apply, and we need to provide kubectl with a manifest for our application. So with the description of the elements we want to deploy. And here we provide a YAML file as input of the kubectl apply command. So we can look at our YAML file. You see that in this YAML file, we define the type of object we want to create and deploy. So this is a KubeDirector cluster. We give it a name. We make sure that this name is unique within our Kubernetes cluster. We define the KubeDirector app we want to deploy. And here you see that we define the number of nodes we want for our application cluster with the role or service role of controller. We also define the capacity of and the size of our containers by defining the memory size, the CPU, whether or not we want to use GPU. In our environment, we don't have any system or Kubernetes host with a GPU, so we set the value to 0 here. And then you can use a kubectl apply command with our YAML file as input to create an instance of our KubeDirector app. So you execute it. After a few seconds, you should see the response of your Kubernetes API command, apply command, to see that your virtual cluster for your application has been created. And you can now check or inspect the status of your application cluster. So you can run the next cell to get the name of your KubeDirector cluster object for your student ID. And you can use the kubectl describe API call for your KubeDirector cluster to check the status of your KubeDirector application and virtual cluster. So after, some of you might see your the status as pending, some others the status as configured. So it takes 1-2 minutes or a few seconds, it depends, to reach the state of configured. configured means that your cluster or your virtual application cluster is now running and is in stable state. And you can see here as in the members, you can see the element of a standard Kubernetes element that has been created by the kube director operator for your application. It created a pod running your containerized application, a service which will be used to access your application, and it also created a stateful set, which is a standard controller on Kubernetes to establish a control loop of your Kubernetes, of your application virtual cluster. You can also use the next command to get a status of all the elements or standard elements that has been created for your application. So you see your pod is running, your service, which is of type node_pore, has been created, and your stateful set as well has been created. And now the next step for you is to connect to your application that has just been deployed. So again, accessing your application is through the gateway host. And for this, we need to get the remapped pore on the gateway host to connect to your application. So you can run the next kubectl describe service command to get the port. So the port here, the remap port on our gateway is 10,003. And to verify that your application is running, just click on or run the next cell, which is a curl command against our gateway URL on port 10,003 for me, which will be a 10,000 different port for you. And you see that you should get 200 OK. So this means that your application is running and responding. And now you may want to connect to it through your browser using and connect to the Jupyter notebook that is embedded with your application to interact with and use TensorFlow to run your machine learning models, for example, and train your machine learning models. So let's get what we call a token. It's a kind of password to connect to your application and Jupyter notebook of your application. So execute the next cell. You should see that your Jupyter notebook login token with a token value. And if you want to connect to your application from your browser, execute the echo command. Your application service URL will give you the URL along with the token password to connect to your Jupyter notebook you just deployed. So you can do a Control-C to copy the value of your URL. You open another tab on your browser and do a Control-V to paste the value. And you are now connected to your application. If you click on TensorFlow tutorials, you will see here a set of tutorials that has been embedded with this instance of your application. And these are a set of classification or regression models that you can use on TensorFlow to train your models. But this is beyond the scope of this workshop, of course, but this is how a typical data scientist or machine learning engineer would use HPE Ezmeral Container Platform to deploy a set of applications and use the applications to train and run their models. And once they finish with their application, they can delete their application to release the resources if they no longer need the application on the Kubernetes cluster. So we can go through now through some cleanup. As a cleanup, we will delete our application using kubectl API call with the delete operations against our YAML file. And then we will, because we are good students, we want to apply the best practices. We will delete or close our login session properly. And then we will reset our environment so we can run again our workshops should we want to run it another time. So this concludes this workshop. If you click on the conclusion link, we have reached the end of this workshop. I hope that you enjoy this guided learning experience. If you find this workshop valuable for you, you can also learn more by looking at a couple of blogs that leverage this workshop to learn more about how to authenticate and using REST API to deploy applications. And if you find, we also ask you to take a couple of minutes to fill out our survey, which is really important for us to make sure that our future workshops meet your need. And should you want to join our community, you can sign up to our monthly HPE developer community newsletter. And by signing up, you can participate to our raffle to win a prize. You can also join our HPE developer community by scanning this QR code. And when you have finished with your workshop, we can simply go to File on the menu bar and log out here. But before logging out, you may want to download the notebooks here and the files for you on your local PC, so you can refer to them offline. To download them, it's very easy. You can select the file one by one, or you can select all the file by doing a Shift key and you select each file. Then you right-click. You have a contextual menu here and click download. This will download all the files on your local PC. And this will download the files with the output of all these files. So you can refer to the not only the commands, but also the output of the commands. So with that, I will switch to the wrap-up section of the. So again, if you can take a couple of minutes to take the survey, you can download the notebooks. If you are interested to learn more about HPE Ezmeral Container Platform, you can connect to developer.hpe.com and you will see a set of platforms from HPE product and solution portfolio. And one of it is the HPE Ezmeral Container Platform, where you will find a lot of resources about kubedirector, as well as blogs and other information about Ezmeral Container Platform. You can join the developer community. You can connect to the HPE developer community portal to hpdev.io or developer.hpe.com. You can join us on our HPE Dev Slack workspace if you want to discuss directly with subject matter experts on HPE product and solutions. It's the best way to establish and connect with engineers is to join the hpedev/slack.com. You can sign up for our newsletters, which is a monthly newsletter, or contact us through email at hpdev@hpe.com. And for internal or partners members, we have a couple of Yammer groups to communicate and connect. With that, I thank you very much.